So this is a tutorial on using Excel to graph. You may have done this before. If not, I hope that this is helpful. The first thing you want to be sure you do is have your data entered properly into the Excel spreadsheet. You want your X values to the left of your Y values. The X values in this case are the concentrations of the different stock solutions in micromolar, and the Y values are the percent transmittances. I've got them ordered from lower concentration to higher. It normally doesn't matter when you graph the order in which they're written, but for some reason, when I was graphing them with 7 up top and 0 on the bottom, my graphs weren't coming out right, and that's never happened to me before. So consider having the lower concentrations up top, the higher at the bottom, in case Excel's acting weird for you as well. Next thing you want to do is highlight the data that you're asking Excel to graph for you. You don't want to include those column headers. Those are there just so I can keep track of which column is which. So I've clicked on the upper left-hand data that I want Excel to graph. My left mouse button is held down, and I'm highlighting all the cells I want Excel to graph. It looks like A2 isn't highlighted, but in fact it is. I then go up to the Insert tab, and I'm going to insert a chart. It's a scatter plot we want to insert. It's an XY scatter plot, which is the same thing as a line graph, but Excel treats them differently. So click on Scatter, and then pick the option to not have Excel draw a best fit line in for us yet. We're going to do that here in a moment. So we're going to pick this just plot the points for us option. Then this quick layout button appears, and if it ever isn't there, it's under the Design tab. Click on it, pick the upper left-hand option, which is the one I always pick, which gives you an opportunity to put a title in to label your y-axis, which in this case will be the percent transmittance, and your x-axis, which in this case will be the concentration in micromolarity. Be sure to put those in. When there's only one data set, you don't really need a legend, so I'm going to click on that and delete it. And again, we're imagining there's a title and our axes are labeled in here as well. The final step is to ask Excel to draw a linear curve fit. Even though this data is not linear, we're going to ask Excel to draw a linear curve fit for us to see how linear or nonlinear it is. First thing we want to do is click on any one of these points with the left mouse button. All the points highlight. If you right click, you've got the option to add a trend line. So I'll click on that, add trend line. And then it defaults to linear, which is what we want. We're going to force a linear curve fit through this nonlinear data, but if you wanted to change it to logarithmic or exponential, oops, you could. Not sure what happened there. Then scroll down once linear's been clicked on, and ask Excel to display the equation on the chart for you for a reason that will be made clear in the lab later. So there's our equation. Of course, because it's linear, it's coming up in the y equals mx plus b format. And then you also want Excel to display the R-squared value for you. This is a statistical value that describes how close to being linear this data set is. We won't get into what it actually means or where it comes from, but the closer that value is to 1 or 1.0, the more linear the data. And an R-squared value of 0.9217 is relatively low. Despite that it seems close to 1, it's relatively low, suggesting this is nonlinear. You want data, ideally, from an experimental data set, if it's linear, to have an R-squared value of at least 0.99 or higher. And that's something that will be our goal, is to find what data set gives us a linear curve fit or an R-squared value of at least 0.99 or higher, or the highest R-squared value possible. That's it on graphing in Excel. Good luck. Enjoy.